There we go. So welcome everyone uh, to the February meeting, the Horicon Marsh Bird Club. I want to thank everybody that's here and online. Also for being a little flexible. Typically we have our meetings the third Thursday, but we were able to uh, get Mr. Drake to commit to a little bit earlier, and we were a little bit flexible. So um, it worked out for everybody. Glad to see it. So first off, we'll start out with just some bird sightings around. Um, there are lots and lots of eagles around. Has everybody been seeing eagles? Yeah, yeah, good. Um, they've certainly really active. Guarding those nests. Some of our coworkers that and some of the folks around that are monitoring nests have seen some copulations and a whole bunch of territorial displays. So it's looking good for eagles. I have seen a few rough-legged hawks, not many. Um, there are a few snowy owls in the area. Um, was able to um, finally get one up in northwest Dodge County, west of Waupun, just in Dodge County by like 200 yards or so. But that one's been fairly regular. So um, we finally got to see one this season. They've been few and far between. Um, I've had we had white-throated sparrows up until about 2 weeks ago. Haven't had any since. Um, Red-breasted nuthatches coming to the feeder. That's been about as extravagant as we've had around here as far as perching birds. Anybody in the audience? Leslie, yes. Oh, okay. All right. Leslie there's had a Wilson snipe on her between her and her brother's property. She has a little bit of open water there. So that's a really good bird this time of year. I know there's a few great blue herons around. Yes. Oh, okay. Um, another uh, somebody in the crowd here had some snow buntings out at west of the marsh here. We had them around when we had snow, and then we kind of lost the snow, and then now they've been pretty tough to see. We haven't had any for a couple weeks now, but when we had the snow, they were certainly around. But we'll get them back on the rebound here as they head north. A few horned larks, not many, um, but and then I did have a northern shrike right after the first of the year. So anybody online have any good birds to add? You can type them in, and if not, so a few upcoming events that we're going to have this Saturday. We're going to have the Cabin Fever event, family friendly event that runs
Liz is online.
9 to 2, I believe it is.
10 to 1, Jeff.
Okay, 10 to 1. Liz, you want to take that take it over if you're available?
Sure, I can do that for just a second. So yes, we have our Cabin Fever event coming up this Saturday from 10 a.m. to 1 p.m. So if you're looking, it's supposed to be nice, as I think we were talking about a little bit beforehand. Everybody's excited to have some warmer weather to get out and about. So that'll be a fun opportunity for folks. Jeff, I'll let you talk Nestbox seminar in a little bit. Um, but then two other events I want to highlight. Horicon Marsh Bird Festival. Registration is live and open. Jeff, you can hit more on that if you want to, but just want to make sure that people know that. And then for spring continuation, we have our Wildflowers for Wildlife sale, which is a native plant sale, and the pre-orders are now open for that. So I'll drop a link in the chat for the Wildflower sale, but basically all of this information can be found in our Friends Group website, which is horiconmarsh.org. And it'll have the full list of all of our events plus pre-order forms and different ways that you can do things. So I'll drop a link for those online, and everybody else, again, that's horiconmarsh.org. So thanks for letting me promote a couple of our upcoming events. We're thinking spring here at Horicon for sure.
So with that, the Nestbox seminar will be coming up March 7th. That's that first Saturday in March. Plans are definitely underway. For that, we're going to have Liz is going to talk about on bluebirds. I'm going to talk on wood ducks, of course, and we're having somebody from the Bat Conservation League, Bat Conservation, talk on bats and whatever we can do in bat boxes and how to put them up and where to put them and all those type of things. So looking forward to that. And then so that will be the 7th. And then on the March 21st, so that's the third Saturday, we're going to be doing nest box checks here at the center. So it's going to be so instead of a meeting on Thursday, we're going to have kind of a combination of a field trip and a little bit of um, learning here at the center on wood ducks and some other nest boxes that we have here, and we'll see what kind of birds are flying over there as well. So that'll be outside, hands-on. We'll meet here at the center. We'll go out, check on some nest boxes. Um, I've got some scouted out that I know have been successful, and we'll take a look at those and kind of dive in a little bit, do a little investigation. Sometimes you get more than wood ducks, and sometimes you get diving into all kinds of other critters. So it's always fun. Like we always say, it's kind of like Christmas. You think you know what you're going to get, but you never really know until you open up the box. So um, it's always kind of fun, interesting. I've been doing some checks here the last couple of days. Came across a screech owl in a box today. Plenty of screech owl pellets around. So I did have a great crested flycatcher nest out on the west side of the marsh here the other day when we were doing some nest checks. So always kind of fun delving into that. So with that, yeah. Oh, I have heard a few barred owl hoots around, some pair bonding kind of going on, some the monkey howl or the chats, the whoop, from our yard. I did see two of them together the other day, so with that, we're gonna dive right in to our presentation tonight. Um, tonight we're going to have David Drake, professor and extension wildlife specialist at the Department of Forestry and Wildlife Ecology in the University of Wisconsin-Madison. He's going to talk about wind energy and conflicts or challenges for flying wildlife. So with that, I want to welcome David, and we'll get on with his presentation.
Wonderful. Thank you so much, Jeff, for the introduction, and thank you, Deb, for inviting me tonight. I really appreciate that. It just warms my heart to hear all this bird talk. So I grew up birding with my parents, and prior I've been at the University of Wisconsin almost 21 years now, which is just shocking to me. But prior to that, I was on the faculty at Rutgers University in New Jersey for 5 years, immediately out of my PhD, and taught ornithology for 5 years there. So I've always had a soft spot in my heart for birds. And so, along with that, Jeff, I will just report from Madison that earlier this week I heard cedar waxwings. Um, so that has been kind of nice that the beginning of spring is coming, I think. All right, so excellent. Well, I really appreciate the invite tonight. We are going to talk about wind energy and flying wildlife. And I am primarily an urban ecologist, so I study mostly animals in cities, try to figure out how animals navigate cities, how they get along with us. But like any good professor, I have reinvented myself multiple times, and one of the reinventions was getting involved with wind energy, and this actually started back when I was at Rutgers University, and then when I came here to UW-Madison, this was actually one of my first real long-standing research projects that actually this is the project that actually really probably got me tenure. So it's a kind of a really nice memory about this. And so this is I'm sure a lot of you are familiar with this picture here, but this is the Forward Energy Wind Farm in Dodge and Fond du Lac County. So that it probably looks familiar to you because of the landscape where you all live and bird. And before I get too far into this, let's see. Oops, let me just click on that. Okay. Before I get too far into this, I want to thank all of the people that have been in my lab that have dedicated their time to this study. And so Reagan was a master's student with me, and I'm going to report some of her work tonight. Julie Garvin and Janan were both postdocs with me, and I'll report some of Julie's work as well. And then Steve Grotsky and Mike Watt also got their master's degree with me. So I'll report some of Steve's work tonight. And Julie is still working in renewable energy out in Oregon for Tetra Tech, which is a environmental consulting firm. And Steve is actually at Cornell University, and he's an assistant unit leader for the U.S. Geological Survey Wildlife Co-op unit there at Cornell. And Steve went on for a PhD in renewable energy and really has kind of developed this field that he calls renewable energy ecology. And he's done a tremendous amount of work on wind, but also on solar. And so it's been really fun to kind of watch his career evolve. And I take some pride in the fact that he actually started that career path when he was with me. And Steve was an undergraduate at Rutgers University, so that's where I first met him, and I was so impressed with him. I said, when you graduate from Rutgers, if you want to go to graduate school, get in touch with me, and he did, and I was extremely happy to have him as one of my students. The other thing about this is some of this research I'm going to talk about today is, like 20 years old. So we were doing this 2008, 2009 when we first started, something like that. So it's almost 20 years old, which is also pretty remarkable to me that time has sped by that quickly. All right, so just to give you some context here, and I will try not to get too political tonight, but I am happy to entertain any questions, and I certainly will not pull any punches. So if you want to delve into some more of the politics of solar and wind and just renewable energy in general, I am more than happy to do that because I am absolutely fascinated with renewable energy, and there are so many different facets to it, not just the ecology of it, not in addition to the engineering of it, but I'll talk about this just a slide or two. But there's a lot of social implication about renewable energy and wind in particular that I just absolutely find fascinating. So, if you want to delve into some of those topics, by all means, I'm happy to have a conversation about that. But just to start off with some context here, this is 2023, so it's a couple years old. But to give you a sense about what powers our country, we're still all other sources is that gray in the upper left-hand picture here. I don't know if you can see my cursor, but this is primarily coal and natural gas and things like that. About 10% of our energy portfolio is powered by wind, and about 4% is powered by solar. Solar is picking up relatively quickly. It started quite a bit out in the West and it seems to be kind of moving east. And then if you want to move down to the lower right-hand picture here, this is just looking at wind and solar alone throughout the United States from about 2015 to 2024. Excuse me. And the blue bars are wind energy. The orange bars are solar energy. And you can see that solar has been on an upward trend, as has wind. But wind is kind of topped off here or plateaued around 2022, and that really has a lot to do with who is in the White House right now, and our energy policy. So we can talk more about that all you want to, but I suspect that if we were to look at this graph in the next couple of years, that you're going to see a dip, starting to see a decrease in wind, and you probably are going to likely see an increase or a continuing increasing trend in solar. So here in Wisconsin, we've got 10 wind farms. As you can see, all these dots or these circles here. The newest one is down in Grant County. I think that was commissioned in 2023. The oldest one is 1999, I think, something like that. And so I think we've got roughly 800 megawatts of wind energy combined across these 10 wind farms. And just to give you some context, roughly 1 megawatt will power, on average, about 305 homes. So if you want to do that every single day. So if you want to do the math, 800 megawatts, 300 homes is what we're looking at. And for a while, Wisconsin had a renewable energy goal that by 2025, so we just passed that they wanted at least a quarter of the energy portfolio to be powered by renewable energy. Again, that's primarily wind, although solar is starting to come into effect more in Wisconsin now. But I just looked up the statistic tonight in preparation for this, and depending on the source and depending on the year, it looks like right now about 12 to 16% of the entire state's energy portfolio is powered by renewable energy. So we're maybe halfway there, but we still have certainly a ways to go. You probably are aware of this, but let me just hit on this a little bit. So there's a tremendous amount of benefit to wind energy. And again, we could talk about renewable energy in general, but we're going to talk about wind energy specifically on this slide. So it really is a green energy source. There is no air pollution. There's no water pollution from wind energy. Once, obviously, there's some pollution with the manufacturing of the turbine and the infrastructure for the turbine. Obviously, you've got to transport the turbine from the manufacturing facility to the installation site, things like that. But once the turbines are installed and they're up, it really truly is a green energy source. And because of that, it's extremely beneficial for the overall environment. The other thing is it's economical. More than 300,000 jobs are supported annually. Obviously, so there are some temporary jobs or short-term jobs with the installation of the turbines, but there's long-term maintenance and depending on who makes the turbine and the turbine type, but on average, the life of a industrial turbine is upwards of 30 years. So that's pretty close to a career for an individual. So there are quite a few long-term jobs supported in terms of maintaining the turbines and the infrastructure that goes along with the turbines there. And I am not exactly sure on this last bullet point, but this is kind of what I've cobbled together from years of talking to people. But when people are hosting a turbine on their land, then they get paid a lease fee, an annual lease fee. And obviously here in Wisconsin, most of the wind farms are built on ag land. And so that's a really pretty lucrative source of kind of off-farm income for ag producers. But $5,000 to $8,000 annually per turbine in land leases, and I've heard as much as upwards of $10,000 per turbine. But that is surprisingly kept kind of quiet about how much each landowner is getting. But if you're a farmer and you're hosting 5 turbines in your property, it's $25,000 in the minimum that's coming into your profit margin, and you really don't have to do anything. It's just passive income, which is pretty nice. So that's pretty interesting about that. There are some downsides to wind energy, which we'll talk about tonight. We're going to focus on the downsides of the flying wildlife, so I'm not going to focus too much on that. But I alluded to this a little bit a couple slides ago. There are a lot of social implications, and these turbines are really, it's a love-hate issue, depending on who you are. I think they're actually kind of attractive on the landscape. I really like them. I'm a big proponent of wind energy and renewable energy in general, a huge advocate of it. But I also don't have one in my backyard, and I may feel a little bit different if I was surrounded by them. But I don't know. So, but the interesting thing about this is when a turbine or a wind farm goes in, excuse me, as I mentioned here in Wisconsin, they're primarily situated on ag land. And so you will have farmers that some farmers don't want the turbines on their property, no matter what the price is, what the lease fee is. Others are willing to gobble up as many turbines as they can. And that's actually, in some of these small farming communities, has driven a wedge between neighbors. So it has actually caused quite a bit of tension within these communities because some people just don't want the turbines there because they think that they're unsightly. There is a lot of, if you go online, there's kind of this dark web of people who believe that turbines cause health issues. There's what's called the shadow flicker. As these turbine blades spin, it creates shadows in people's houses, or can create shadows in people's houses. And some people think that that's not healthy for the inhabitants of the houses. Excuse me. People also claim that the turbines are interrupting their TV coverage, radio coverage, things like that. But there are a lot of people, I shouldn't say a lot, but there's a solid number of people, and there's a lot of information on the web that people truly believe that wind turbines cause health impacts and negative health impacts. There are no peer-reviewed literature studies or no peer-reviewed research to support that suggestion. But again, people still believe that. So there's some really interesting social implications about wind farms on the landscape. All right. There are different types of impacts to flying wildlife, and I want to now shift our focus to just wildlife here. So we're going to talk about the two types of flying wildlife we have in Wisconsin. Obviously, are birds, and then we've got bats, which are mammals, the only true flying mammals. We're not going to talk about flying squirrels because they're not part of this. They're not impacted by wind energy. Excuse me, I'm just getting over a cold, so I'm going to try to limit my coughing, but that's where all this is coming from. So there's a number of impacts. So one impact is direct impact, and that is from either a bird or a bat colliding with the turbine or the infrastructure. And with wind farms, generally, all of the overhead lines are undergrounded. So all of the power lines from the wind turbine generating that electricity, those power lines go from the nacelle, which is that kind of rectangular box at the top of the monopole that's holding those 3 turbine blades. The power lines go from that nacelle through the turbine monopole into the ground, and then they're connected to a substation, and that's where it comes up above ground. But when we're talking about direct collision, it's with directly colliding with something to do with the turbine. So it's either the spinning blades, most likely, or it's the monopole. It's not overhead lines, not overhead power lines. Indirect disturbance would be either that birds primarily and or bats would be disturbed in the sense that once the turbine's put in, they may choose not to nest in that area, where in years past, before the turbine went in, they may have nested in that area, or they may avoid the area altogether. So they actually may abandon those areas, those territorial areas, if they're a territorial raptor, for example, or they may abandon some territorial nesting areas and just avoid that area altogether. And then, so those are two of the longer term impacts. A shorter term impact is the habitat modification when the turbine is actually being installed. And so there is generally, as you can see in this picture down here, there is a generally a gravel path or a two-track that is plowed in from a paved road to the turbine pad. And at that pad, then they will mow down all of the vegetation. And typically, again, it's cornfield or soybean field generally. So that's what they're mowing down. And at that turbine pad, then when they construct the turbine, they'll enlarge that pad so they can get the cranes there and all the semi trucks and all the material to construct that turbine. And then once the turbine is constructed, that pad actually shrinks in size as relatively small, but the road still stays there. So that habitat modification issue is really more of a short-term temporary impact than it is a long-term impact. All right, so what I'm going to talk about tonight is the Forward Wind Energy wind farm that is still in existence there. You can see, obviously, you don't have to worry about the Wisconsin map because you know where you're located, but it's at the northern edge of Dodge County, and it bleeds just into the southern edge of Fond du Lac County. And as you can see here on this lower right-hand corner map, all those red dots are the turbines, and there's 86 turbines scattered across 32,000 acres. And then each one of those green dots was a search area that my students and then other volunteers searched. And I should have mentioned this. Let me back up for just 2 seconds. Sorry about this. When I was calling out and acknowledging all of my students, I also should acknowledge all of the public volunteers that helped us. And I saw that Tom Underwood was on here, and I know Tom was one of our volunteers. And I recognize a few other names. And I apologize if I don't recognize everybody, but if you want to kind of just put up in the chat or just call out at the end of this that you are a volunteer, I would love to hear from you, because without your dedication, there is no way that we could have conducted all of this research, because it was so labor intensive. So Tom and everybody else who may be on here, and even if you weren't on here, if you were involved in helping us search for birds and bats, we are forever indebted to you. The other thing I should say here is in this study area, 97% of the study area is ag land. And again, I've talked about this a couple times already, but that is the case for just about every wind farm across Wisconsin, is that they are primarily situated in ag land. And that's true for most wind farms across the United States. Excuse me. As you go out east into New York, Pennsylvania, things like that, sometimes wind farms are situated on the forested ridges. And so there's a lot more habitat modification and longer term habitat modification, because they're actually taking down trees and are keeping that area clear of woody vegetation for the life of the turbine, life of the wind farm. All right, so we did a tremendous amount of research at this wind farm here, and we were out there for about 4 years over the course of maybe 2008 to 2000, I think 15, 16, something like that. So we were involved in 2008, 2009. We were doing post-construction mortality searching. And then 2000, I think it was 15, 16, we were out there doing a follow-up study on just raptors. So we did a lot of research out there. And I want to generally share with you kind of what we found. And what we found is pretty general and pretty typical of what other research has found at other wind farms, regardless of where you are. The exception with that is the very first wind farm in the United States that is out in California that had a tremendous amount of avian mortality. But since then, they've modified that wind farm. Years and decades ago, they modified it, and they've really cut down on that avian mortality considerably. But generally, this trend that you see here in this pie graph is true for just about every wind farm in the United States. And this is what we found at Forward Energy, is that generally bats are much more affected than birds are. And so that's one of the things that, again, I will try not to get too political here, but President Trump was just at the National Prayer Breakfast, and maybe some of you heard some of his comments, but apparently one of the things, well, not apparently, one of the things he did talk about is he went on a bit of a rant, as he tends to do, against wind energy. And one of the things he talked about, and this is a common refrain, when he goes on rants about wind energy is that wind turbines kill all the birds. And that is absolutely not true. Wind turbines are much more impactful to bats than they are to birds. And I'll explain that in just a minute. Okay, so as I mentioned, we've done a tremendous amount of research out at Ford Energy, and I want to just cover two studies that I think are relatively unique based on some of our findings here, because some of the other things we found in terms of and what we published on in terms of the types of birds we were finding, the types of bats we were finding, things like that. Again, I don't want to diminish it at all, but it's certainly there's not a lot unique to Ford Energy that other wind farms in similar type landscapes were not finding. But these two studies I want to report on were unique to what we were finding here, and I think are pretty interesting. So one is this idea about bat mortality, and Steve Grotsky published this paper along with a number of other co-authors in 2011 in the journal Mammalogy. And I believe you can find it online if you just Google Grotsky et al. 2011 Journal of Mammalogy, that it should come up. I think it's available in the open access. But one of the things we started talking about with Steve was barotrauma. And as we were starting our research, there was a research team up in Canada that published a paper. And in their paper, they were suggesting that one of the primary reasons that bats are so much more impacted in terms of mortality than birds are is this idea about barotrauma. And so barotrauma, you can think of it as the bends from a human diver. So as a diver goes down deeper and deeper into the water column, there's more external pressure that's pushing on that body. And eventually, if you go deep enough, eventually what's going to happen is your organs will implode. And that's what this research team out of Canada was suggesting. What they published is that they had done a tremendous amount of searching under these turbines, found a lot of bats, and they did necropsy or animal autopsy on bats. And what they were suggesting is that bats were not dying from direct collision. They were suggesting the vast majority of bats were dying from barotrauma. And let me explain this a little bit more for you. So as these blades spin, and then typically a wind turbine will have 3 blades, and they spin, and it doesn't look like they're spinning all that fast. But if you go out to the tip of the blade, as that blade's spinning, it's spinning over 200 miles an hour, depending on the wind speed, and sometimes even higher than that. But what happens is bats are flying, and bats, we've seen this, and other people have seen this, and there's some really cool infrared photography and video online where they actually can show bats that are kind of following the spinning blade, the tip of the blade, almost like a dolphin porpoises in front of a boat. And so we know the bats can avoid the blades if they want to. But what this research team was suggesting is as bats are flying through the rotor swept zone, so that's that area, if you were to draw a circle and connect each one of those 3 tips, inside that circle would be the rotor swept zone. So what this team out of Canada was suggesting is on the very front side of this, blade or this rotor swept zone, you have high pressure, and then as you go through the rotor swept zone on the back side of the blades, you have a pressure drop. So you've got low pressure. And what they're suggesting in this paper is that bats are able to fly through each one of those blades through the rotor swept zone. But as they do that, they are hitting this really quick pressure drop. And because bats don't have as strong internal skeleton as birds do, that as they hit that pressure drop, their internal organs are actually imploding. So what's happening is their heart is just collapsing onto itself, their lungs are collapsing onto itself, and they're essentially dying of barotrauma. We see with birds, and I'm sure you may have seen this as well, but birds can also navigate these turbine blades as they're spinning, and they can fly right through that rotor swept zone without getting hit by the turbine blade, and they can fly through that pressure drop, but because the skeleton of birds is so much sturdier, that they can endure that pressure drop much better than bats can. So we read this paper, and I said to Steve, this is really interesting, and I don't know if I believe this or not. And so Steve and I started talking about this, and we started recruiting some other researchers. And so we wanted to investigate this idea behind what is actually killing the bats. Is it barotrauma, or are they actually colliding with the turbine blades and it's just being disguised as barotrauma? So that's what we were looking at. And there's a number of objectives we have. You can see that. But the one I want to talk about is this one that's highlighted, where we were using veterinary diagnostics to determine what was actually killing these bats. And so what we would do is we would go out and collect bats, and then we worked with some veterinarians at the Wisconsin Vet Diagnostic Lab here on campus. And so they did a bunch of histology for us. They would slice the inner ear, and they would do lung sampling for us, and they would put it on slides and look at what these bats look like internally after they've gone through this turbine blade pressure drop. We also got bats from the Dane County Health Lab that had been reported and killed and sent in for submission for rabies. So we knew that those bats didn't have barotrauma, were not exposed to wind turbines at all. And so that was our control, what we were calling a healthy bat, so to speak, even though that they perhaps had rabies, the rest of their body was healthy. And so we found some really interesting things. And I'm going to start off in this upper left-hand corner here in 3A. So that is a histology or histogram slide of a healthy bat lung. And you can see that there's a lot of interstitial spaces there denoted by the different colors. If you look to the upper right, that's a bat that we examined that we found at one of the turbines, and this is common with a number of with most of the bats that we did histology on. But you can see here that all those cells within the lung actually have exploded, and so the lung is just filled with blood, and it's not within the cellular network. So that's a really good example of what happens when a bat goes through that pressure drop. Is that lung just implodes and essentially kind of busts open, if you will. The bottom two pictures I want to show you, 3C, is the normal inner ear of a bat. And obviously with bats, they need that inner ear for balance. So because they're flying and they eat on the wing, they need to understand, what's up and what's down, and they need to be able to be very maneuverable in the airspace. And what allows them to do that is a functioning inner ear. And so you can see on the lower left-hand picture there, I want to show you just where you see W in that black arrow. Just take a look at that inner ear membrane there. And then over where X is, to the right of X, just look at the general shape of that inner ear. That's what a normal, healthy inner ear looks like. If we go over to 3D, now you can see the arrow on the left that where just above Y, that inner ear has ruptured. And that's why you see that pink or the blood is filled with that inner ear there. And then if you look at the upper right-hand arrow over there just to the left of Y, you can see part of the inner ear actually it has herniated and is bulging in. So as those bats go through that pressure drop, it ruptures their eardrum, and it has significant negative impact on their inner ear. And I'll talk a little bit more about that in just a second. The other thing we wanted to find out, and this is Steve Grotsky here. He doesn't look much different, maybe a little bit grayer because he's got a couple of kids now. But the other thing we wanted to do is find out if it's direct collision. We would expect that we would see some skeletal damage to the bats, like they would break a bone or have head trauma or something like that. However, if they're actually getting killed by barotrauma, if they're breaking their bones, are they breaking their bones from actually kind of falling down through the air to the ground? And when they hit the ground, that's what's actually causing the skeletal damage, if there's skeletal damage at all. So we had to determine that. And the way we did that is we took these bats that were submitted to the health lab for rabies testing. We x-rayed them to determine if there were any skeletal injuries. And then Steve took, I think, 25 of the bats up to the top of a wind turbine. He climbed up the monopole with the permission of the wind farm and kind of kneeled down on the nacelle. And then he just kind of gently dropped these bats off the nacelle. And this is probably 250-ish feet off the ground, something like that. And then after he did that, we went down and we marked each bat, so we knew it was a bat that we dropped off the nacelle. We went down and found all those bats. And then we did post-drop x-rays to see what does that look like. And here's what we found. So we found that these bats were actually having really significant skeletal injuries, and it was not from being dropped off the nacelle. it was actually from hitting the turbine. So these are bats that we found in our searches, and we x-rayed some of those bats as well. And so what you're seeing here, if you want to start off in the upper left-hand picture, is you're seeing a compound fracture right here with this the bat wing here is compound fractured and is completely dislocated from the shoulder joint, if you can see that. And then if you move over here to the left, there's another compound fracture on the other wing over there. If you look in B here, the upper right-hand picture, you can see, I don't know if you can see my cursor or not, but there's compound fractures of the jaw right here. There's a fracture up here at the front of the head, and there's a skull fracture right here as well. Moving down to C, you see a herniation of the intestinal wall right here, which is really interesting. And you also see a compound fracture of the wing bone up here. And then again in 4D, I'm sorry, oops, let me go back here. In D, the lower right-hand picture, again, we see a complete severe dislocation from the shoulder, and then we also see compound fractures. So these are 4 different bats, but this is representative of what we found for other bats that we x-rayed that we found in our search area. So what we found from our radiology is that that bats actually were not breaking bones if they died from barotrauma and they just kind of floated down to hitting the ground. They were not breaking bones from hitting the ground. They were actually breaking bones from actually flying into and colliding with most likely the spinning turbine blades, but also possibly the monopole, but more likely the spinning turbine blades. And so what we found in our survey here is that 74% or almost 3/4 of the bats had at least one broken bone. And if we were not to do the x-ray at all, we were just to visually inspect the bats, that we would have just by visual inspection, we would have recorded about 1/3 fewer broken bones than what we found with the x-ray. Fractures of the wing were the most common, but no fractures of the hind limb. So all the fracture was on the interior. It was all on the front part of the bat. So from the face, the head, and then the shoulders and the arms. So all the anterior portion of the bat. So what we concluded is that we did not think the barotrauma was the dominant mortality or dominant source of mortality. It probably is a bit of both. There's some barotrauma, there's some direct collision, but there was definitely direct evidence for direct collision. There was some definite evidence for barotrauma, but not nearly to the extent that the research team from Canada suggested. So we were refuting the results in that regard. But most likely it's a mixture of both, but not predominantly barotrauma. The really interesting thing, though, is that over half the bats we examined had significant ear damage. And so that obviously has a real significant impact on their ability to survive, because once that ear gets damaged, they are not nearly as effective as a flying animal, because they don't know which way is up. They can't be as maneuverable. And because they do feed on the wing, that has a significant negative impact on their nutrition, and also has a significant negative impact on their navigation. Some of these bats that we are finding are migratory bats. So we've got 8 bat species in Wisconsin. 4 of them migrate out of the area in the winter. The bats that are state residents here that actually hibernate in the winter, there's some evidence that they will actually undertake short distance migrations, so upwards of 300 or 400 miles to go to a hibernaculum. So it's impacting all of the species, even if they're not a true migratory bat. Bone fractures obviously are affecting quite a bit of flight, and most likely there's quite a few crippled bats. And so this has some real significant impact, because when we go and we go out and do these searches, we have to develop a calculation to determine a mortality or define a mortality estimate. And one of the things that goes into this mortality estimate is that we define a search area under each turbine that we want to search, and then all these searchers will go out on a regular occurrence, and they will very systematically search the entire search area. And then based on the number of mortalities we find, be it birds or bats, then we'll calculate a mortality estimate. Part of that mortality estimate is based on searcher efficiency. So how good are the searchers at finding the mortalities? And we would test the searchers for that. The other factor that goes into the calculation is scavenger removal. So if a bat dies and it falls into our search area, we may not ever see that bat if it gets scavenged by a raccoon or a skunk or a crow or a house cat or something like that. So we have to determine scavenger removal rates. One of the things along those lines, however, is if a bat has suffered sublethal effects, so the bat actually is still alive, but it has inner ear damage, it's crippled, or it's got a severe skeletal impact, it may be able to fly far enough to get out of our search area and then die outside of our search area, so we would never find it to begin with. So if that's the case, that a lot of these mortality estimates that are being reported in the literature, we would suggest are severely underestimating bat mortality. And that obviously has pretty significant impact on the population estimates of bats, which we know very little about because we just don't understand as a science, we don't really understand very well the demographics of bats. So we don't know how long they live typically. We don't know how many pups survive from being a young bat and make it into a maturity into an adult bat. Obviously, we know that bats are long-lived animals, but they also are very, very slow reproducers. So if we are significantly underestimating bat mortality at wind turbines or wind farms, in addition to the mortality that's being undertaken with white nose syndrome, predation, and everything else, that we may actually be having a lot more significant, serious ramifications to population, overall population estimates of bats. So that was an interesting study that we undertook and an interesting finding that we think was unique to some of our research here. All right, one last thing I want to talk about, and then I'm more than happy to answer questions, open up for discussion, whatever, is a study we undertook looking specifically at raptors. And Reagan Daum was a master's student, so she published this in Frontiers in Ecology and the Environment in 2019. Again, I believe this is online, so if you want to Google this for more information, you can do that. So I believe it's open access. One of the things that we kind of was an ongoing objective of our project here is to look at pre-construction versus post-construction. And here in Wisconsin, if you're not familiar, I'll try not to go down too deep into the rabbit hole here. But if you're not familiar with how wind turbine or wind farms get sited, in Wisconsin, if a wind farm is over 100 megawatts, they automatically have to get approved by the Wisconsin Public Services Commission. And if they go through the Public Services Commission, at the time that we were doing our research, the Public Service Commission required the developer of that wind farm to conduct 2 years of post-construction monitoring. So essentially what we were doing, where we were searching under the turbines, so 2 years post-construction monitoring. And so we did that for Forward Energy. We were contracted to do that for Forward Energy. And we were looking at not only dead things, but we were also looking with avian species and raptors in particular. We were looking at our wind turbines displacing raptors from that airspace. And so we were looking at abundance, diversity, and behavior. And this was really interesting. So what we found here is we were not involved in the pre-construction survey, but for 1 year, there was an environmental consulting firm that was contracted by Forward Energy, and they went out and they conducted a year's worth of pre-construction surveys of bird surveys, raptor surveys, and I believe that they also had acoustical monitoring for bats. So you can see here, this is relative raptor abundance. So this is total number of raptors per hour. So it doesn't matter what the raptor is, but it's all raptors that they saw per hour. And so it's, maybe 12 raptors per hour or something across the entire wind farm. When we went out and replicated their study in 2008, 2009, what we found is that there was a significant decline in raptor abundance in those 2 years post-construction. And you see that there was a decline from 2005 to 2008. There was also a decline from 2008 to 2009. However, when we looked at the data for 2009, it's not reflected in this graph because we're looking at all raptors that are summarized together. But if you break this out into species, we were seeing some raptor species in terms of their abundance starting to tick back upwards. They were still significantly declined from 2005, that 2005 pre-construction survey, but they were starting to kind of climb back up in terms of abundance from 2008. And so that got us thinking. We said, well, what would happen if we go back and we do post-construction survey, but instead of doing it 2 years immediately post-construction, we do it like 7 or 8 years post-construction. So that's what Reagan's master's project was on. We wanted to look and replicate the raptor abundance study from pre-construction, those 2 immediate years post-construction, and then we went back 7 and 8 years later. And what we found in 8 years later is that the raptor abundance recovered to the level that it was before the wind farm was ever built. So we found no statistical difference in overall raptor abundance 7 and 8 years later relative to the pre-construction. And as a matter of fact, raptor abundance had recovered from the 2 immediate post-construction years. So that was really interesting to us to see that over time that raptors are going to return. It might take a little bit of time for them to do that, and we don't know exactly at what point between 2009 and 2015 that occurred. It could have happened in 2010 or 11. We don't know because we didn't survey then. But that was really interesting to see that if you give at least raptors enough time, that they will respond and they're going to come back to that area, and it's going to be as if the wind farm was never there to begin with. Again, we don't know what that would look like for songbirds because we didn't conduct that type of research. So this is our study area. I just want to share a little methodology with you. If you see the reference or control areas, let me see if that, so yeah, here we go. The reference areas are R1 and R2. So on the northern edge of the wind farm boundary and the southern edge of the wind farm boundary. Now, when the pre-construction survey was done, they had a rough idea about where the turbines were going to be and where the boundary of the wind farm was going to be, but not all of the lease agreements had been signed. And so they weren't exactly sure where all the turbines were going to be set. So they set the reference boundaries as best they could relative to the project boundaries, and the project boundaries are within the wind farm boundary. But as you can see, that red line here, that the project area 1 is outside of the wind farm. So we didn't have true control areas relative to treatment areas here. And so what we did instead is we conducted the survey just like they did in 2005 and just like we did in 2008 and 2009. But what we did, because we needed to demonstrate that we had a true control area. And so instead of using the R1 and R2 here, what we did is we looked at breeding survey data for routes that were definitely outside the wind farm boundary. And we looked at the abundance of raptors at those breeding survey routes to see if what was going on with the raptor community completely outside the wind farm relative to what was going on with the raptor community in or adjacent to that wind farm. And so I want to point that out, that's how we determined what our control data was. It was looking at breeding bird survey for the raptor species we were interested in. Excuse me. Now here's 5 species that we looked at. There were a couple other species, but these 5 are interesting here. So turkey vulture, red-tailed hawk, and a accipiter. So accipiter obviously is primarily Cooper's hawk or sharp-shaded hawk. We lump those 2 species together into a accipiter. And as you can see that these 3 groups, or the 2 species and the 1 group, that in 2005, you can see that's the orange bar, that's the pre-construction year. 2008, 2009, each one of these 5 groups or species we looked at, they had a significant decline in those immediate 2 years post-construction. And then for the top 3 species or groups here, turkey vulture, red-tailed hawk, and accipiter, that they actually came back, and there was no, at least by 2016, there was no significant difference between 2016 and the pre-construction year. Now, for northern harrier and American kestrel, we still saw a significant decline in the harrier abundance and kestrel abundance even in 2015 and 2016. But if you look at the overall breeding bird data for these two species, that they are struggling a little bit statewide anyway. So we don't think that decline, even in 2015, 2016, is directly and solely due to the wind farm or the presence of the wind farm. We think it has more to do with some other factors that are not directly related to the wind farm. And then this is the other thing I want to report really quick. So we don't have the 2005 data here because it was a little messy. But 2008, 2009, again, are those two immediate years post-construction, then 2015, 2016. And just to show you this, excuse me, the year is along the x-axis. The y-axis is representing proportion of behavior activity. So when the students were out surveying, and all the volunteers were out surveying for raptors, what we did, let me back up really quick. I'm sorry, for the raptor survey for both 2008, 2009, and 2015, 2016, we dedicated a sole person to the raptor surveys because we didn't want, if we saw differences in behavior, we didn't want the differences to be a result of how a different reporter is reporting that compared from reporter 1 to reporter 2 to reporter 3. So we had the same reporter, the same observer do all of the raptor surveys and raptor behavioral data so that we could eliminate that variable in the model. So what you see here is the red bar is high risk behavior. So that would be examples of a raptor flying within 100 meters or 100 yards of a spinning turbine blade, flying through the turbine blade, flying through the rotor swept zone, or getting what we would consider close to a operational turbine. The purple is no response, so that means that as the animal is flying through there, they just kept on going. They didn't deviate their route. They didn't change altitude if they saw that turbine. They just kept on going like nothing was happening. And yellow is avoidance. So what you can see here is there was a considerable amount of high-risk behavior in 2008. And 2008 was right after, that was the first year after the wind farm became operational. So these birds were probably still trying to adapt to the turbines and the spinning turbine blades on the landscape. You can see, again, that primarily is high risk behavior, some no response, and a little avoidance. In 2009, the high risk behavior dropped, but there's also an increase in avoidance behavior. The no response behavior kind of held steady there. But if you look in 2015, 2016, the high risk behavior dropped pretty substantially. The avoidance behavior didn't change, but what really changed was the no response behavior, which is a suggestion that these birds have become habituated to the operational wind farm and that they understand how to navigate around those turbines without having to deviate course very often and things like that. But it's having really no impact on these birds at all. So we thought that was pretty interesting also. All right, so that is what I have for you. Let me see what time it is. It's 7:30-ish. So I probably should quit talking anyway because I've been talking for a while. I want to acknowledge, again, DNR was a huge partner to help us here, as was Fish and Wildlife Service, Public Service Commission, University of Wisconsin. And Invenergy is the parent company of Ford Energy. And they were the ones who funded all of the study, all of the post-construction research here. So we acknowledge and appreciate that. So thank you so very much. And I can leave this picture up, Jeff, or I can delete it or stop sharing and we can see everybody's face, whatever you wish to do.
Okay.
You can leave that up, Dave.
Okay. And I see Mark's got his question up. Mark, it's good to see you over there. Thanks for your hand.
Okay. Yeah, I've got some real good news about bats with wind turbines. I was to a talk in the last 2 weeks with Paul White.
Yep.
And Paul's one of the big bat researchers and bat people in the DNR. And they've been negotiating with the legislators. There's a law that says they've got to reduce the mortality on bats with wind turbines. And it's taking place for the first time. All the legislation's been approved. It's been approved, I think, for a while, but it's taking place in 2026. And when the bats are moving through, and there's a good chance they could hit the turbines or get killed, impacted, they are going to have to turn off the turbines. And I forget if Paul thought it was going to reduce mortality. I can't remember this for sure, but maybe by at least half or impacts. And what it's going to cost in energy, it's the turbines, if they close them down when the bats are moving, they're only going to be producing 99.5% of the energy if then in a given year than if they'd have left them on. It's only a half of 1%, which is really good news. And sometimes the bats are migrating through or whatever, but they got high winds, they're going to let the turbines run because the bats don't fly when it's high winds. So it's a lower wind speed. And he said that's going to make a really big difference. So that's the good news I was going to let you know about.
Yeah, no, that's great. I was just visiting with Paul on Monday because I have another new graduate student who's starting up, and she's going to do some analysis of their archival data sets on bats. So we were just visiting about this, as a matter of fact, on Monday, which is really interesting coincidence. Yeah, so a couple of things about that, Mark. You alluded to the fact that typically at lower wind speeds, and we didn't find this because we didn't examine it, but other researchers have documented that at lower wind speeds, that's typically when you get higher bat mortalities. And what is suggested is that as the wind speed picks up, it blows the insects out of that area. And so because there are no insects, the bats are less likely to be attracted to that area because there's no food source for them to feed on. At that lower wind speed, that the insects are not getting blown out of the area. And so bats, as they're feeding, that's when they start colliding with or interacting with the turbine blades, the rotor swept zone, and all of that. And so that's true that at those lower wind speeds, that's when they would typically turn those turbines off so the blades can't spin. And because the blades aren't spinning, then the bats are not going to get killed by that moving infrastructure there. The other thing that's interesting about this is that there's been a lot of research to look at different types of mitigation to try to reduce the amount of bat mortality. And so for example, they've painted the blades intermittent black and white or black and orange, for example, or they've, just like bats use echolocation, they've tried to reverse that to kind of almost set out alarm calls to bats to say, hey, stay away from this area. And nothing has been effective. The only thing that's been effective is to actually turn the turbines off. And typically when they would turn them off is during nights of heavy migration in the fall and the spring, during low wind speed nights. And that has demonstrated to be very, very successful to drastically reduce bat mortality. One last comment about that. What's really interesting about that, however, is Invenergy is a private company, and they are funded by venture capitalists and investment firms and investors as a private company. There are wind farms in Wisconsin, like Blue Sky Green Field, just north of Ford Energy, that is a public service company. So like a public, like MG&E or Light Energy. The interesting thing about this, and I don't know if this is still the case, but when I was talking to Invenergy about this years ago and suggesting, could we do some research to turn off the turbines on some of these low wind nights, high migratory nights, they said no. And the reason they said no is because they were on the hook to the investors, and the investors were not supportive of turning off the turbines, even though, Mark, as you suggest, it really does not impact the bottom line all that much. But the investors wanted to maximize their profits. The public energy companies like MG&E and Alliant Energy, they're more receptive to turning off the turbines, partly because of the public relations of doing so. But if they are suffering some bottom line profit issues, they can pass that on to the rate hike. They can do a rate hike and pass it on to the users of the energy. So I thought that was really interesting, the dynamics of a privately funded wind farm versus a publicly funded wind farm.
David, so I had a jack my memory bank here. So I was had just a small part in two of those um, investigations or
Okay.
studies. One was there were grids that were underneath the turbines during the construction phases.
Yep.
Um, and I just one summer uh, went and searched those grids, and like you had said, it was pretty much confirmed that we didn't have any bird mortalities, but I did find some bats underneath them.
Hmm.
So, and then uh, later on, once the turbines were up and operating, there was a study for birds and was by the Fish and Wildlife Service. Uh, they used radar to
Hmm.
detect
Yeah.
migrations through the basically had to do with cranes and if and that's when they were going to release the whooping cranes in the area,
Yeah.
kind of study the crane movement through that. And so they would find these flocks of birds coming out of the marsh, detect them with the radar. And then my job was just like, okay, what kind of birds are they? I don't know. That's a flock of blackbirds. And and uh, and then if it was cranes, then they would note it on there. Um, just my observations there, most of the birds, they navigated right around them. The
Yeah.
cranes were really good. The only thing that the Canada geese that were coming out of the marsh were really freaked out by them. They
Yeah.
got to the point, and then the flock broke up, and they scattered and turned around, and they were much more affected. The cranes just kind of navigated right through it.
Yeah. Yeah. So, and we saw that, especially with Reagan's mortality, or I'm sorry, post-construction project in 2015, 2016, we would see both whooping cranes and sandhill cranes that actually would fly right through that rotor swept zone unfazed. So that was kind of interesting. This wind farm here, as part of their permitting approval by the Public Service Commission, they were required to actually move I guess it would be the eastern boundary further back. So they were further away from Horicon Marsh, and it was out of concern for the Canada geese, all the flocks of Canada geese that were flying through there. And the last thing I'll mention, Jeff, in response to something else you said, is you talked a little bit about searching and finding more bats and birds. And I do want to say it's not that birds aren't getting killed. There are some birds getting killed at wind farms, the ones we search, the terms we search, but as well as wind farms across the United States. But typically, it's those birds are getting killed because of direct collision. So they are actually colliding with most likely the spinning blade. But even if you were to add up all of the mortalities for the avian species on a continent-wide basis, it is not impacting the continent-wide populations for the vast, vast, vast majority of these species. So that they're able to reproduce and counter the mortality from the turbines.
Okay, we'll be right with you, Mark. We've got a question online. Colleen, Mary, want to know what countries have the greatest presence of wind farms?
Yeah, yeah. So it depends. The United States is pretty solid, but a lot of countries in Asia and Europe, but a lot of those wind farms are offshore. So if you go to Germany, Holland, up into the Scandinavian countries, there's a tremendous amount of wind energy production, but a lot of it's offshore, not onshore. And then if you go to Asia, especially China, they have it onshore, but they have also a considerable amount offshore. And obviously here in the United States, the very first offshore wind, I think is actually I sailed past this a couple summers ago, so I'm trying to remember how many it was. I think it's three turbines off the coast of Rhode Island. There was a wind farm that wanted to go offshore off of Cape Cod, but the Kennedy family killed that because it was going to ruin their viewscape. And now obviously there's some other wind projects that want to go offshore here in the United States. But as a matter of fact, I think I saw a news article a week or two ago that that the Trump administration stopped the permitting process of that, and I saw a federal judge allowed that to go through. So they may be able to actually build offshore off the East Coast. And then there was some, I don't know the status of it because I don't keep up with this as much anymore. But there was some interest in putting offshore wind in the Great Lakes. But as of now, there's nothing in the Great Lakes.
Okay, Mark, another question.
First a comment, then a question. The comment is there's a new wind farm going in Columbia County, in southeast Columbia County, from Columbus, basically northwest to Rio. And it's going to be 40 turbines over like 48,000 acres. And the difference is going to be, compared to the ones that we're looking at on your photo there, the difference is that these are twice as high. They're
Yeah.
going to be like 260 feet into the air. And I think 40 turbines, if I remember right, is enough to power 100,000 homes.
Yeah.
It's significant, and I assume these people are probably getting paid more than $5,000 a site.
Yeah, so Mark, let me just make a comment in response to that. So these turbines, each one of these turbines you see here is a 1.5 megawatt turbine. So it can produce a maximum of 1.5 megawatts of power at any given time. The newer turbines can produce upwards of 5 megawatts, and I'm not sure what's going into Columbia County, but the newer turbines are more powerful, can produce more energy. But obviously, the more energy they produce, the larger they become, and so you increase that rotor swept zone for sure. And I'm not sure what the price of that is, but each one of these turbines you see here is about $1 million a turbine to construct it and to erect it. So the bigger they are, the more money that's invested in the infrastructure for the turbine.
So what I was going to say is Southern Wisconsin Bird Alliance, formerly Madison Audubon, has a property 3 miles south of Rio. And we don't allow any hunting there. We've got a nice wetland. Usually have maybe 1,000 to 2,000 geese there, probably about the same number of mallards in the fall. Field feeding, because it's part of it's surrounded by large areas of corn and beans. No woods or anything like that. So they're going to put there's 3 turbines that probably within a mile, the way it looks of that. And what impact will that have, do you think, on the birds? There's still, I'll say this, there's still a lot of vacant fields if they go straight to the west or that. But, these are big turbines.
Yeah.
Have an impact on
Probably not. Probably not on birds. They probably have continuing impact on bats. But again, the I think anything that is standing upright on the landscape, this tall, it has the ability to impact birds, but probably more episodic, or like an episode here and there, not necessarily continuously like you see a continual impact of bats. But we had done some research prior to getting involved with the wind farms here, where we looked at impacts to vertical structures like television towers, radio towers, things like that on migratory birds. And I'm sure you all know that on these nights where the ceiling drops down because of a front coming through, that actually pushes the birds down because they're migrating by sight more than anything else, and they need to see the ground as they fly. So as that cloud ceiling gets closer to the ground, it pushes those birds closer to the ground, and then obviously anything that's tall standing up above the ground has the potential to impact birds. So what I would expect, Mark, probably would happen is that on those nights during heavy migration in particular, where you have a low ceiling, that's when you probably are going to see more of an impact to the birds. But on clear nights and other times when you don't have these fronts coming through during migration, I doubt that you're going to see any more of an impact than we saw here.
But what I was saying too, we got 2 types of birds, I guess. We got the migrating birds, But my comment is, we've got ducks and geese there that are
Yeah.
field feeding. And
Yeah.
if we have monster turbines close by, I mean, are they going to stop feeding in those fields if we had enough of them? If all the
Yeah.
fields around us had 260-foot high wind turbines in, we might not have any fields that are open, or I mean, that they
Yeah.
want to feed in, pick cornfields
Yeah.
and
Yeah.
things. That's my question.
Yeah, yeah, that's a good question. I don't I'm not familiar. Again, I have not kept up with the literature because I don't do this type of research anymore. But at the time, I was not familiar with any studies that had gotten at your question, where what's the impact to feeding birds. But if I recall correctly, I think it was in Spain. There was a study that looked at nesting birds in the vicinity of wind farm, and they again did a pre-construction survey and a post-construction survey. And what they found in post-construction is that both the number of nests and nest productivity declined within the boundary of that wind farm. So there's clearly it was an impact to nesting birds. From ducks and geese, I don't know, Mark, honestly. And you know, with those animals, they habituate pretty quickly, and I would suspect that they probably are not going to be impacted significantly. I wouldn't think, but that's just my gut feeling based on you know
Mhm.
past experience.
Thanks.
But only one way to find out.
Any other further questions? Anyone? Okay, we got one here in the audience. So the question was, Leslie saw an article where a different type of wind turbine
Uh-huh.
where it had vertical fins versus a
Yeah.
rotating. It
Yep.
turned around a axis.
Yep. Yep.
Any question or any comment on that? What?
Yeah. Yeah. So if let me see if I can draw the picture for everybody here. So these blades are kind of in a horizontal plane. So they're just like a fan blade, if you want to think about that. What Leslie's talking about is a different turbine design. So you still have a monopole that's standing straight up out of the ground, similar to what you see here in the foreground, which is that base, if you will. And then instead of having the three blades that are horizontal, what they have is like a helix, almost like a DNA helix, that is going around the center pole there. And as the wind blows, that helix is spinning around the central axis, which is vertical versus horizontal. And so I don't know. I haven't seen any research on the impacts from those, but I would suspect that they would have almost no impact on birds or bats simply because that helix is so much closer to the central axis. And it's only as tall as that central axis would be. Um, but if I recall this correctly from some of the engineering studies I saw, that those helix vertical type turbines are not nearly as efficient in producing energy, and that's why they're not there. You don't see them very often.
So question from the audience: do we have a number of how many bats or birds are affected by this um, wind farm per year?
Uh, Boy, that's a good question. We estimated how many. I would have to go back into some of our research and our papers that we published, and no, I can't recall that off the top of my head. I will tell you again from a bird standpoint that the number of birds that are being impacted, it does not. It would be highly unlikely if it had any impact on the overall population of the species that we found affected from a mortality standpoint. Bats, again, we just don't know enough about bats to know the impact it would have on overall populations. But if whoever asked that question, if you want to email me, I can see if I can find some of our papers. I know I can find them, but I can go back and look at it because we did develop a mortality estimate for this particular wind farm for both birds and bats. And I can go back and see what that looks like, what that number is, and I'm happy to share that with you if you want to share your email with me.
We'll do. I'll pass that along, David.
Okay.
I know just in that area, and I know that area, it's not a high density population of birds there
Yeah.
anyhow. It's
Yeah.
99% agriculture. So
Yeah. Yep. There's a lot of monoculture. That's right.
okay, Mark.
I was going to say with the cave bats, there's only three mines or caves or mines that they're using in Wisconsin. Nita Mine in Dodge County and the two up in Bay City and Maiden Rock. And
Yeah.
so it makes a difference if you got a wind turbine farm in Portage County where there's not close to any migrating bats, and see what they come when they migrate. I assume to Nita Mine is
Yeah.
you don't all come there and the next day they're in the old mine shafts, but they probably go out and feed. So that's probably the critical thing is to keep these wind farms a certain distance
Yeah.
away from
Yeah.
the mines.
Yeah.
Uh,
We published a paper on that too. We did kind of a little modeling scenario, and I can't remember exactly what we found because it's been so many years and I'm getting older and my memory's not what it used to be. But we looked at that because there's Forward Energy is the southernmost wind farm, and then you go up to Fond du Lac County, you get Blue Sky Green Field, and you go up one more, and I forgot what that other wind farm is, but Nita Mine is intermixed amongst these three wind farms, and so there was some concern about what's the impact of these birds, or excuse me, of these bats flying, navigating all these wind farms to get to their hibernaculum. And I just don't recall exactly what we found, Mark. So I apologize, but I can get that paper for you as well if you want.
Thanks.
Last call for questions.
Yes, can you hear me?
Yes.
You mentioned the double helix design that's not as efficient. But is there anything else being done as far as the design and construction of wind farms to reduce bat and bird collisions?
No, not really, because becomes a simple engineering issue about how you capture as much wind as you possibly can. And right now, the most efficient way to do that is to build a larger one of what you see in the picture here. And as I mentioned, these were 1.5 megawatt turbines, but they're installing, I think, upwards of 5 megawatt turbines now. And obviously, as the turbine gets bigger, the overall turbine gets bigger. The way to get 5 megawatts is they increase the blade size for each one of those blades, the blade length, and so you start increasing the rotor swept zone, and so you start taking up a larger planar surface area in the vertical plane there, and you just start eating up more of that planar area. You start having a potential for a greater impact. So there's my knowledge is there's nothing more efficient than what you see here. They just make it bigger. But again, it's a renewable issue, and this is the thing. And I mean, I'm as guilty as anybody else. Every time I flip the light switch from off to on, I want my lights to go on. Yes. And so somehow, we've got to produce energy for all the needs that we have, not only in our country, but in the world. And so it's a matter of which poison do we want to pick. And is it going to be wind energy? There's solar energy is a wonderful renewable source, but there's issues with solar energy based on more habitat modification and destruction. So from that standpoint, you get into nuclear energy, you get into combustible fossil fuels. I mean, there's always going to be some consequence. It's just a matter of how best can we mitigate the consequences negative for um, like the social cost, be it wildlife, environmental damage, the social implications of tearing communities apart for people who want turbines and don't want turbines. So it's just about how best can we navigate all those issues.
That's a cost benefit analysis.
Yeah, 100%, Eric. Absolutely.
Thank you.
All right, we have one more from our audience here.
I'll take questions all night long. So as long as people have questions, I'm more than happy to talk about this stuff. I think, Mark, are you the one who's got the question, or is it somebody else?
From our audience, I'm listening to the question. I'll repeat it for you. So you can... So the question was, although the number of bats, they don't know the number of bats, but the low reproduction of bats with only one pup a year, um, could that harm our local populations?
Yes, absolutely it could. Yeah, if you look so this is you get into additive versus cumulative mortality at this point. So the question is, if you don't have these turbines on the landscape, are the bats going to die anyway, just some other way? So that would just be mortality, the background mortality, or is this turning out to be added mortality? Is this adding to mortality, and it's another source of mortality that if the turbines weren't there, you wouldn't have that mortality? And that's the question that we just do not know enough from a scientific community, because we don't know enough about bat demographics. But if you think about all the mortality that's being suffered from white nose syndrome, although some of the bat species are starting to recover from that a little bit in Wisconsin, at least. But if you look at disease mortality, mortality from predation, mortality from wind farms, we don't know if the reproduction is enough to offset the mortality, but most likely not, because they're such slow reproducers.
My comment, David, is you made the comment about
Doesn't have
habitat.
that data. Yeah. So the question was how many bats were killed in that, and I said you didn't have that information.
Yeah, we have it in one of the papers we published. I just don't recall it offhand. So
Okay.
I can try to find that paper and share it with you, Jeff, and then you can maybe share it out with the group if you'd like to do that.
Okay. Mark?
David, my comment is you made about habitat destruction for solar farms.
Yeah.
Well, I'm a solar farm. I'm sitting under 26 panels right now, and we're putting another 9 in of new panels, better technology. And if people would be there's plenty of buildings, parking lots,
Yeah.
to put them on.
Yep.
And if everybody would be doing that,
Yep.
we wouldn't need 2,500 acre
Yeah, that's right.
taken up for solar farms all over
Yeah.
the place.
Yep.
So
No, there's again, I don't recall the specifics of this, but there's been some pretty fascinating studies that have looked at potential for solar energy in the United States, based exactly on what you talked about, Mark, putting them on people's on the roofs of houses, as well as the industrial facilities and things like that. So you don't actually have to put them directly on the ground. But yeah, we have the potential to produce a tremendous amount of renewable energy through solar, and just passive based on the infrastructure we already have on the landscape.
I just got to follow up on this. There's an Invent Energy has a farm down by Cambridge where Bird Alliance just bought a big farm, and the locals down there they like it if they're getting the panels on their land at $1,000 an acre, and they don't like it if to start with. But some of the people thought to start with, Invent Energy said our solar farm by Cambridge is going to provide enough electricity for 70,000 homes, and they assumed, well, that's right. I could see all the solar. We're going to power my electricity for my house. And
Yeah.
then they found out it's going to power 70,000 homes in Chicago.
Yeah.
That's
Yeah.
that didn't go over the best when people
Yeah.
finally
No.
realized they're looking at the solar panels.
Yeah. Yep. No,
Yeah,
I get it.
I think you would have a much bigger buy-in if that electricity produced would stay locally, not
Yeah.
only with, solar or the wind farms. With the wind farms there, you've got the landowners that, the lease are benefiting, and that's about it.
Yeah.
So,
That's right. Yeah, a lot of times though, these renewable sources, especially the industrial renewable sources, like an industrial wind farm or industrial solar energy, or even if you've got solar in your prairie, for example, that sometimes you're producing a surplus, and then that surplus gets sold off on the market. So even if you are trying to keep the energy local, there's no guarantee you can, especially if you're producing a surplus, because they're going to sell that surplus as fast as they can to get out of the market. The one thing, however, is that if we look at this, more globally, is I understand that in Cambridge you're looking at those panels every single day, and you're bearing the cost of looking at those, even and the energy is going to Chicago. But even though the energy is going to Chicago, that's less energy that they have to produce from fossil fuel to power Chicago. So you're still doing good overall globally. You just may not be doing as well locally.
okay. Thanks, David. Uh,
Thank
all,
you.
inspiring talk, cutting edge science. We always got to think about what we do and how we impact things, and how it impacts our native community and our
Yep.
natural community. So want to thank you, and um, with that,
You-
thanks much.
Thank you very much, and thank you for everything that all of you do. Going out and watching birds and getting that information out is as important as anything else in the world, because you're sharing natural history knowledge with people, and that is very, very important as well. So thanks for everything you're doing.
Good night.
Bye bye.